All right, in this video, we are looking at linear equations properties. And specifically, we're going to be looking at the arithmetic properties. The arithmetic properties are listed on your Keystone Exam Formula Sheet, which is what I'm looking at right now. This is the formula sheet. It takes up the right side. You don't have to memorize these properties. What you have to be able to do is identify when and how they are used. That's what we're going to look at today. First, let's give a brief explanation of each of these properties and hopefully break down the words for you, because if you can remember the words and what the word actually means, it helps you to identify when it's being used, and you don't always have to look back at this list. Let's start off with inverse. Another name for inverse is the opposite. So the additive inverse, or the opposite of add, is to subtract, right? So over here I see I've got a positive number a, and I'm going to add its opposite, which would be a negative number, which is essentially the same as subtracting. All right, addition and subtraction are opposites. So when you add the opposite, you get 0. They cancel each other out and nothing is left over. All right, now let's look at the next one, multiplicative inverse. Multiplicative inverse, well, we start off with multiply. The opposite of that is divide. All right, and if we divide, that's the same as multiplying by a fraction. So here you see we have a, and we are dividing by a. All right, and that's what we're looking at there. So when you see that fraction 1 over a, you're really dividing by a, and that's what it represents. And in this case, we get 1. Now, it's unique that the additive inverse gives us 0, and the multiplicative inverse gives us 1. And I want to jump down from here to the identity property, because it will explain why we get 0 when we do the additive inverse and why we get 1 when we do the multiplicative inverse. Because the inverse properties go hand in hand with the identity properties. Because notice what the identity property is here for addition, and notice what it is for multiplication. The additive identity property is the first one shown here, and it says that anything plus 0 is itself. Identity meaning that it doesn't change its identity. A stays a when we add 0 to it. In other words, it doesn't change its identity. And that's the purpose of the inverse. The inverse gets us the identity property so that we can then use it. Because if you don't want to change anything when you're adding, well, then we do the additive inverse to get to 0, and 0 plus that number doesn't change it. So that's why the inverse gets you, the additive inverse gives us 0, and the multiplicative inverse gives us 1. Take a look at the multiplicative identity. Anything times 1 is itself. Notice A did not change. It's showing what we can do to something so that we do not change the way it looks. All right, and that's what the identity property is. Things maintain their identity. The inverse and the identity often go hand in hand. Okay? Now let's take a look at the ones that I jumped over in the middle. Commutative property. Well, to commute, all right, you commute to school every day. You commute on the bus or your parents drive you, but you go from home to school and then back again. That's commuting. Your parents probably commute to work unless they work from home. To commute is to move. And in the commutative property, we're looking at the terms themselves, A and B here, and we're watching them move. All right? So they then swapped. B came over here and A came over there. The terms moved. Addition is commutative because you can change the order of addition without changing its value. All right? And we'll look at some examples of that in a moment. Multiplication is commutative as well. We change the order. Associative property. The associative property, an association or to associate, means to group. If you associate with a certain group of friends, all right, then you gather together with them. Maybe you get together and do things outside of school. Maybe you associate with a certain group at the cafeteria where you go to a certain table and you sit down with them. To associate is to group. It doesn't change the order of the terms. Notice we still have A, B, C, and here it's A, B, C. The order did not change, but what changed was the groupings changed. In mathematics, we show groups by parentheses. We changed the group of the parentheses. Now, parentheses in our order of operations tell us what to do first. So what we're saying here is that in addition, it doesn't matter which one you do first. If I'm adding A, B, and C, it doesn't matter if I add A and B first and then add C, or if I add B and C first and then add A. The order of addition doesn't necessarily matter which way we're grouping these. So associative property changes the groupings. It changes the parentheses and what we're putting together as a certain group in mathematics. It does not change the order of the terms. So that's commutative and associative. Most of the time people do mess those up. Commutative changes the order of terms. Associative changes the groupings. All right, now the next one we're going to look at is distributive property. That's down here. You've been dealing with distributive property for a while now, and that's anything times a group. You would multiply each item in that group. Now here we're seeing a monomial times a binomial, but you could do a monomial times a trinomial or a polynomial. It doesn't matter how many terms are in the group. Whatever's out front being multiplied into that group needs to be multiplied into each value of that group. So we see then it's A times B and A times C. All right. Multiplicative property of 0 is something that you learned a long time ago, and it's just given it a fancy title now, and that is anything times 0 is 0. All right, anytime we multiply by 0, we get 0. The next two here, all right, I'm going to say are the golden rule for solving equations. The golden rule for solving equations is that whatever you do to one side of an equation, you have to do to the other side of the equation. That's essentially what they're saying. If A is equal to B, because of that equal sign right in the middle there, then A plus C would be equal to B plus C. Now, I'd often show it like this. When we're solving an equation, if I would add C to this side, then I would add C to this side, and I'd get my new result. All right? It's basically saying what you add to one side of your equation, you must also add to the other side of the equation. Same with multiply. All right, so if I multiply one side of the equation by C, I have to multiply the other side of the equation by C in order to keep things equal. It's a property of equality because the goal is to keep things equal. That's why it's of equality. And that's why the golden rule is what really applies here. Now, do they have a subtraction property of equality and division property of equality? Yes, they do. Why aren't they on the list here? Well, that's because an additive property of equality really covers it. Because you can always add a negative, which is the same as subtracting, and multiply, you can always multiply by a fraction, which is the same as dividing. So really, they're only focused on these two right here, but it still applies that what you do to one side of the equation, you must always do to the other side of the equation to keep things equal. And that's our properties of equality. What do you do in order to keep equations equal? So that's a brief explanation of them. Let's give some examples, and then we'll practice. All right, we're going to start off practicing here with our commutative and associative properties. As I look at this, they give some good examples. 2 plus 3 is equal to 3 plus 2. You could set your own example, and you could practice this if you want. Try to write some down on your paper. But essentially, I want to show you that 2 plus 3 is 5, and 3 plus 2 is also 5. They equal each other. 2 times 3 is 6, and 3 times 2 is also 6. They're equal. But let's get a little bit challenging this. What if I said 2 minus 3? Well, is that the same as 3 minus 2? No, it is not the same. 2 minus 3 is negative 1, and that does not equal 3 minus 2, which is 1. And I'm showing you that it doesn't work for subtraction, but how could I be creative with the subtraction? If I wanted it to be equal, 2 minus 3, and I wanted to change the order, I could rewrite it as negative 3 plus 2, because I'm essentially seeing the beginning here as 2 plus negative 3. And therefore, it makes it an addition problem, and addition is commutative. So if you do want to switch around subtraction problems, you can change it to adding a negative, and then you can just move that negative with that sign. The key is that this negative sticks with that 3, so it's still with that 3 over here as well. All right, and that's one way that you can change it there. As we look at this, let's take a look at the associative property. Down below, 2 plus the group, 3 plus 4. Our order of operation says I have to do this first and get 7. And then add that to 2, and 2 plus 7 is 9. And what if I did it in a different order? Well, 2 plus 3 is 5, and then I'd have to add that to 4, and 4 plus 5 is 9. We see that they are the exact same, and they are equal. So we can do that. All right. Notice at the bottom there, 2 times 3 times 4. Well, 3 times 4 is in the parentheses, so I do that first. And then I multiply that by 2, and I get 24. On the other side, if I do 2 times 3 first, I get 6. And 6 times 4 is 24. Once again, we get an equal value on both sides of that equation, showing us that it is true. You must be careful if we look to maybe do some things like this. So minus Just want to give you an example that looks like this. All right, what if I test this one out? If I've got some negatives in there, some subtraction. Well, this is going to give me 2 minus 12, which is going to give me negative 10. And does that equal what we get over here? Well, 2 minus 3 is negative 1, plus 4 is going to be 3. Notice it does not work. You've got to be careful. This would actually be the distributive property. We'd have to distribute that negative, saying that it's not just minus 3, but it's also minus 4. And you can see over here, that was not the same if I just moved my parentheses. So you've got to be careful. You can only do the associative property with addition and multiplication. It doesn't quite work the other way around. Let's take a look at a few of our other ones. Identity property and inverse property. All right, identity property and inverse property basically showing you that if you add 0 to 2, you get 2. If you multiply 2 by 1, you get 2. I'm keeping the identity of that original value. All right, and you can do that with any number you want. 2,481 plus 0 gives me 2,481. All right, anytime we add 0, it doesn't change the identity. But where is this really useful? Let's take a look at a fraction here for a moment. What if I had 1/2 and I wanted to multiply that by 1? Well, if I want to change the way the fraction looks, I can multiply it by a creative one. Let's say 5 over 5. That's a giant one. And if I do that, I get 5 over 10. This is where we use the identity property of multiplication because it gives us equivalent fractions. And we do that to get common denominators all the time. And this is saying that 1/2 is still equal to 5/10. They're the exact same number, even though they look different, because I did not change the identity. All right, that's where the identity property comes in. Inverse property, as I said, this goes hand in hand with the identity property, and 2 plus negative 2 is 0. All right, and then 2 times 1/2 is 1. Where would we actually use this? Well, I want to give an example. Let's just go x plus 2 equals 5. If I had an equation and I wanted to solve this equation, what would you do? Well, you would subtract 2 from each side, all right? Because plus 2 minus 2 give me 0. And then 0 plus x is x, and it gets rid of that positive 2. Doing the opposite undoes it because it's the inverse. Inverse means opposite. All right? And so that's how we find out that x is equal to 3. That's how we use the additive inverse. All right? What if I wanted to use the multiplicative inverse? Where have I seen that before? Well, take a look at an equation. Let's go 2x equals 8. All right, what do you do to solve that equation? Well, it's 2 times x. I do the opposite, which is to divide by 2. That's what we see right here. All right, multiplying by half is the same as dividing by 2, because 2 times 1/2 is 2 over 2, which is 1. All right, and notice what happens here. If I divide both sides by 2, I find that 2 over 2 is my giant 1. So 1 times x, and as we saw with the identity property, 1 times x is x. And that's where the identity property comes in with the inverse property. We use it every time when we solve equations. All right? Now, let's get you some examples. Let's go ahead and practice. All right, this is the time in the video to practice, so I would encourage you in a moment, but not yet. I'm going to give you the instructions, but then pause the video and try and do this. So if you don't have a piece of paper, you're going to need one. Get a pencil, write things down. What I want to do here is I want to identify what property is being used here. Now, if you don't have the formula sheet in front of you, you can go back to another tab. You can pull it up into another tab. You can always find my formula sheet inside the assessments folder. It's always right at the top, so you have that so you can look at it. So I encourage you to have that out so that you can use it at this time. And I'm going to give you a heads up now. Some of these problems on this paper are using properties that we're not going to focus on right now. They are properties that exist, but they're not the properties that we focus on for the keystones. So just ignore those problems. I'll cross them out when we get to them. All right, so pause it right now. Take a look at these first. Just take a look at the problems 1 through 4. Just do these ones right up here. Pause it, and then come back to me. See if you got those answers, and then we'll move on to the rest of the page. All right, I'm assuming right now that you paused it, and you're coming back now. Let's go through this first one. As I look at the first one, I see it was x plus y is equal to y plus x. That was the commutative property. All right, and specifically the commutative property of addition. All right, we changed the order in which we were adding, so it was the commutative property. On the second one over here, we see what changed. Well, the terms didn't move, but the parentheses did. That is our associative property. All right, and it's our associative property of multiplication. I'm going to use a dot to represent multiplication there because we're multiplying our terms. Let's look at 3. Well, k plus 0 is k. K did not change its identity. All right, so it's the identity property. All right, and this is technically the identity property of addition, or known as the additive identity. And then we look at number 4. Once again, we see that we took our terms, 3t and 2r, and we changed the order of them. And therefore, if we change the order of them, that is our commutative property. And here we're looking again at the commutative property of addition. All right, so at this point, I want you to go ahead and I want you to pause the video. And now I'd like you to complete 5 through 10. Pause it now. All right, coming back in, let's see how you did. Let's look at the next one. 6 was outside the parentheses, and then all of a sudden we multiplied 6 inside the parentheses. That is distributive property. Here we've got 100 times 0 is 0. That is the multiplicative property of 0. Big word there, big title. All right, anything times 0 is 0. In the next one, our terms stayed in the exact same order, but we changed our groupings or our associations. So it's the associative property, and in this case, it's the associative property of addition because we're adding our terms. In this next one, notice what changed. PQ became QP. We changed the order of multiplication. All right, it's our commutative property of multiplication in this case here. Next one, number 9. 9, gx becomes xg. Again, we're changing the order of multiplication. Our terms moved, so it's the commutative property. They commuted. And in 10, careful, they're giving it to you a little backwards here, but it's 15 times the group, means 15 times c, and 15 times d. That is our distributive property. All right, and it's distributing the 15 into our group. Good work. If you feel good, great, stop the video. If you want more practice, I'm scrolling down to do more. All right, give me a moment before you pause the video. I'm going to cross out the ones we're not doing. Again, they're not properties we're focusing on, even though they are properties that do exist. We're just not going to talk about them just yet. All right, take a look at what remains. I'd like you to pause the video and try to do those. All right, I'm assuming you come back in now and you want to see how you did. Let's take a look at the first one. 0 plus b is b. b did not change its identity. Therefore, we are looking at the identity property of addition. All right. 14, once again, 4 did not change its identity. 4 times 1 is still 4. And so we're looking at the identity property of multiplication. 15, 1 times y is y. We did not change the identity of our multiplication there. Y did not change its identity. And then anything times 0 is always 0. That is our multiplicative property of 0. And then 5 plus 0 is still 5. 5 did not change its identity, and this time we're looking at the identity property of addition. All right, now I'm going to scroll down to a new part that I'd like you to see, and let's take a look at this next problem. All right, in these problems here, this is similar to what you might see on the Keystone exam. You'll definitely see something like this on our test. And we want you to actually identify how these properties are being used when we're solving an equation or simplifying an expression. And here we're simplifying two expressions. Don't be confused with the equal signs. I'm going to explain how it works. You're not actually solving an equation. What they're doing is they're starting here with this expression. And then that expression becomes this expression, which becomes this expression, which becomes this expression, which becomes this expression. And they're asking you to identify what was done for that to happen. So on this first one here, they want you to identify what happened on that change. Then, whoops, writing the same number here. I want to write it 2. All right. Then on the second change, when we get to this one here, what happened to get there? On this third change, what did you do to get there? And then on the fourth change, what did you do to get there? All right, so that's what we're looking at. I'm going to show you this first one as an example, and then I'd like you to pause and try to do 28. So looking at this first one, I had AB outside of the group, and now AB is being multiplied to each value in the group. That is our distributive property. All right, now going from this step right here down the next one, we're going to follow that arrow down step 2. All right, what happened in step 2? Well, they changed our parentheses. Sorry, they did not change the parentheses. I get ahead of myself. They changed instead the order in which I'm multiplying. Notice I had A was here and it moved there, and I had AB switched to there. All right, so it changed the order of multiplication, so that is commutative property, and specifically commutative property of multiplication here, because we're multiplying our a times the ab. Then I got ahead of myself last time, I apologize. Then they changed our parentheses. Notice my parentheses were here around AB, and now they're here around AA. Here they're around AB, and now they're here around BB. They're helping us to understand that B times B is B squared, A times A is A squared. But to do that, they used the associative property. And again, we are multiplying these terms in which we're changing the parentheses in, and so it's the associative property of multiplication. Step 4, in this case, it's not really a property that we're looking at. They just combined like terms in a sense. They multiplied, or otherwise known as simplify. All right, they simplified things here. And that's what they're looking to do. AA could be easier written as A squared. BB could be easily written as B squared. And they combined like terms if they could. In this case, they can't. You'll see sometimes in that step they'll combine things, and we'll see that down below. So in this last one here, this last step going from here to here, all right, I'm going to tell you right now, that is just simplify. And it's not really a property, but it's the last step that they did there. All right, so I want you to try and go, what did you go from here to here? That's the first step. Write that here. Going from here to here, that was the second step. What property did they use? From here to here, what's the third step? What property did they use? And here to here, what's the fourth step? What property did they use? Okay, don't worry about that last step. Step number 5, I already did that for you. Okay, I want you to try and figure out those first 4 steps, what properties they did. Pause the video, go for it. All right, if you're coming back in, hopefully you did it already, and let's check to see. We took 5 outside the group, and I distributed it into the group, so I used the distributive property. All right, and then after I did that, I took 5 times 2, and it moved over here. 5C moved over here, and what was in between them? That was addition, so I changed the order of addition. That's commutative property of addition. And then once I did that, now all of a sudden I added parentheses around here. Now this is one that could be confusing because you think, oh, associative property changes the parentheses, but essentially that's what we're doing. There were no parentheses, and we changed them. We added an association. We changed the grouping. All right, anytime you change the grouping and it's not going to change the value, it's the associative property. All right, and I changed the grouping of addition here because I'm adding the values inside the group that I made. All right, once I did that, notice what happened from this group down to here. All right, now all of a sudden I have a C outside the group. They did the opposite of the distributive property. It's still the distributive property though. Still represents the distributive property. We will know that as something called pulling out a GCF or factoring later on. But for right now, it is the distributive property. That's why we can do it. The distributive property allows us to do that. All right, I hope that helped. Get more practice, go to Study Island, or come see me in class, and good luck.